Hello everybody, today we'll be working on exponents and powers, so let's get started. Let's say there's a value 9 raised to power 3. Here, let's see what is the base and what is the exponent. Basically, the base is 9. Why? Because, let me write it here. Yeah, so 9 is the base. Why? Because the base is always the number written in the larger font. The number written in the smaller font on the right corner, on the top right corner, is the exponent, or it is also known as the power. So the base is the number multiplied, and the exponent tells us how many times do we multiply the base. This means that if it is 9 raised to power 3, we are not going to multiply 9 into 3. No, we are rather going to do 9 into 9 into 9 3 times. So 9 raised to power 3 means 9 into 9 into 9. We are multiplying 9 with itself 3 times. We are not going to multiply 9 into 3. Alright, let's do one more. Let's say that we have to expand 4 raised to power 5. In this case, 4 is the base and 5 is the exponent. So when we expand this, we know that it comes out to be 4 into 4 into 4 into 4 into 4. That means we are multiplying 4 with itself 5 times. Why? Because the exponent is 5. That tells us that we have to multiply the base with itself 5 times. Now with this, we know what our base is, what are exponents, and what are powers. The next topic we are going to move on is writing an expression as an exponent. So let's say that this is the expression we have to write as exponents, t into t. So we know that the base is t because that is what we are multiplying, and the number of times t occurs is the exponent. Easy, isn't it? Alright, let's try one more. Let's say it is a into 2 into b into 2. So the exponent for this becomes a is occurring 2 times, so it is a squared. 2 is again occurring 2 times, it is 2 squared. And b is occurring 1 time, so we say b raised to power 1, or same thing as b. Let's try one more. Let's say c into c into b into b into a into c. I would like you to solve it first and then we'll do it afterwards. Alright, hoping you've done it or attempted it once. Let's see what would be the answer. When you write it as exponents, you'll find out that c is occurring 1, 2, 3 times. So c raised to power 3 multiplied by b is occurring 2 times, b raised to power 2, and a is occurring once, so you can write a raised to power 4, 1, same thing as a. So it is a raised to power 1, which is the same thing as a. Now we talk about the fourth topic we are going to cover, that is laws of exponents. Now there are a number of laws of exponents, and to understand those laws, let us know one thing. I'm going to tell you the laws and explain them with the help of examples. Later on, we are going to verify them. Before we start with this topic, I wish that you should know that I will be using 4 letters as variables, namely a, b, m, and n. A and b would be the bases in this case, and m and n I'll use them as exponents. So let's get started. So the first law of exponents states that if there are 2 values, a raised to power m, and we're multiplying this one with the second one, a raised to power n, in this case we know that the bases are same, both are a, so same bases, and only the exponents differ. When we are multiplying such values, we need to know that we don't need to first find a to the power m and then a to the power n and then multiply them. That's too lengthy to do. So what are we going to do in this case? To simplify this, we have come up with a law. That is the first law of exponent that states that such an expression gives out the value of a to the power m plus n. So if we are multiplying a to the power m, that is a value, and the second value a to the power n, that means base is same and exponents differ. In that case, we're going to add the exponents and write the base as the same, that is a. Let's check. If it is 3 to the power 2 into 3 to the power 1, then we'll say 3 to the power 2 plus 1, because base is the same and exponents differ. So 3 to the power 3. Let's verify. 3 to the power 2, that is 9, and 3 to the power 1, that is 3, and when we multiply 9 and 3 we get 27, and 3 to the power 3 is also 27. That means it is verified, and it is indeed very true. Now above I have mentioned the first law of exponents, so let's move on to the second one. The second law of exponents states that if there are two values, a to the power m and a to the power n, and we're going to divide them, and the base is same and the exponent differs. Very important, base is same and the exponent differs. We are going to subtract the exponent, that is a to the power m upon a to the power n gives out the value of a to the power m minus n. So in this case, we don't need to first calculate a to the power m, then a to the power n, and then divide them. Simply we can take the base as a for the answer, and then we are going to subtract the exponent. So it comes out to be a to the power m minus n. Let's verify. Let's say it is 2 to the power 4 minus 2 upon 2 to the power 2. So this becomes 2 to the power 4 minus 2, so 2 to the power 2. 2 to the power 4 is 16, and 2 to the power 2 is 4. So 16 and 4, and 2 to the power 2 is 4. So when 16 by 4 gives you 4, which is equal to this, hence verified. Above I have written this as well. Let's move on to our third law of exponent. Now the third law states that if there are two values with the same exponents, in this case, in the previous case, we had the same bases and different exponents, but in this case we have the same exponents and the different bases. So if the powers are the same and the exponents differ, in that case, when we are multiplying two values, the exponent will be copied down right here as the exponent for the answer, and we are going to multiply just the bases. So that means a to the power m into b to the power m gives you ab to the power m. Let's verify. Let's say that it is 2 to the power 1 into 3 to the power 1, and in this case we are just going to multiply the bases because we know it is a to the power. This is a and this is b, and these two signify m. So m is copied down here, that is 1, or I'm just going to do it like that. Yeah, so it is 1, and 2 into 3, that is 6. 6 to the power 1 is the same thing as 6, isn't it? So hence verified. Now with this we are done with our third law of exponent. Pretty easy, isn't it? If a base has a negative power, then we are going to write it as 1 upon a. So a to the power minus 1 gives you 1 upon a to the power 1, which is same as 1 upon a. Similarly, if I say that it is 3 to the power minus 3, don't say that it is 3 upon 3 to the power 3. No, it is not so. It is 1. Wait, let me clear this out. Yes. So this is equal to 1 upon 3 to the power 3. So it means that if there is a negative power, you are going to do the reciprocal for the base and the power becomes positive. Now we are done with 4 laws of exponents, and the fifth one says that if there is a power on the power, that means a to the power m and whole power n. So there are two powers. In this case, it's very easy. We are going to just multiply the powers and the base would be the same. So if it is 2 to the power 3 to the power 6, it becomes 2 to the power 3 into 6, or 2 to the power 18. So these are the 5 laws of exponents, and we are done with this topic as well. Now we are going to simplify statements. So basically we have to simplify this statement: 2 to the power 2 into 8 to the power 2 into 3 to the power 5 divided by 6 to the power 2 into 3 to the power 1. So before solving, we need to break all the composite numbers and get them to the prime factors form. So we have to write them as multiplication of the prime factors. Let's get started. So 2 is a prime number, so it is copied down as the way it was. So 2 raised to power 2 into. Now 8 is 2 raised to power 3. So 2 raised to power 3, that is 8. And now we have to take the power of 8 as well. That is 2 in the question. Into 3 already is a prime number. 6 can be written as 2 into 3. But don't forget to see the exponent for 6 over here. It is 2. So it is 2 to the power 2 into 3 to the power 2 multiplied by 3 to the power 1. Now in this case, 2 to the power 3 to the power 2 becomes 2 to the power 6, because we are going to multiply the exponents. So this becomes 2 to the power 6. Now these are in multiplication with the same basis and different exponents. So this becomes 2 to the power 8, because we are going to plus or add the exponents. So it is 2 to the power 8 minus 2, because this is in division. So this goes up, it becomes minus 2. So it becomes this, that is 6 into 3 to the power 5. Now what we are left with is 3 to the power 5 by 3 to the power 2 plus 1 by 1, because 3 can be written as 3 to the power 1, and these both are in multiplication, so we're going to add these and it becomes 3 to the power 3. So this over here becomes 3 to the power 5 minus 3 is equals to 3 to the power 2. So the answer comes out to be 2 to the power 6 into 3 to the power 2. Now we need to expand expressions. Let's see how. This number can be written as 800 plus 40 plus 6, and this can be written as 8 into 100 plus 4 into 10 plus 6 into 1, and this can be expressed as exponential form. So it can be written as 8 into 100 is 10 to the power 2, because there are 2 zeros. So 10 to the power 2 plus 4, 1 0, 10 to the power 1, and when we're multiplying with 1 there is no 0, so we say 1 is 10 to the power 0. So 6 into 10 to the power 0. And also you can add this in the laws of exponents, that anything to the power 0 is always 1. So a to the power 0 is always 1. Now let's get back here. Now we are done. 846. First we had written this as 800 plus 40 plus 6. Then as the multiplication of 8 into 100, 4 into 10 and 6 into 1. 1 can be written as 10 to the power 0, 100 as 10 to the power 2, and 4 as 10 to the power as 10 to the power 1. So 8 into 10 to the power 2 plus 4 into 10 to the power 1 plus 6 into 10 to the power 0 gives us 846. Now let's see how do we write numbers in standard form. If we write this in decimals, we can say it is 8460.00. So first of all, what is standard form? It means that we need to write this number 8460 with the multiplication of 8.460 or 8.46, because zeros will cancel out in the end, so it's 8.46 into a power of 10. So we need to make this equal to this. The basic idea is this. So 8460. Now we can say that there are 3 digits after 8. So we can say that it is 1, 2, 3. If we want the point here, we need to divide it by 1000. But so we are going to write 8.460 into 10 to the power 3. Simple. But in here we need to cancel out the 0. So we are going to cancel out the 0. We are going to say 8.46 into 10 to the power 3 is the answer. Let's try one more. Let's say we have to write this 10.8 into standard form. Now we need a decimal over here. So this is equal to 108 by 10. And over here we need the decimal over here. So we need to add a 10. Now what you have to do is multiply with the number of zeros you have added. This 0 was already there because the number is 10.8. We have added only 1 0. So we are going to multiply with only 1 0. So this becomes 108 upon 100, that is 1.08 into 10, that is 10 to the power 1. Simple. Let's try this. Let's try one more. So in this we want the decimal to be right here, and the decimal is right now here. So how many places do we have to shift this? 1, 2, 3, 4, 5. Actually it is the number of digits after the first digit, and those many zeros. So it has to be 86000. That makes it 5 digits. So that means that 9.86. We'll not write the zeros as I told you earlier. It makes no difference as such. 9.86 into 10 to the power 5. Now why does not it make any difference to write the zeros or not? It is because that if we expand this to this actually means this 5 zeros after 1. Now if we say that we have to make this number this, we need to multiply it with 5 zeros. We know that if there are no digits after 2 digits, so that means 2 zeros cancel out and this moves here, so it becomes 986. 3 digits are still left and we need to add 3 zeros to it. So this has become the same thing. So this is why even if you don't write any zeros, it makes no difference. Now that we are coming to the end of this video, I hope you like the video, and today we have discussed all about exponents and standard form and expanded form. So I hope you are clear with the concept now. Thank you and have a nice day.